Welcome to the Explainer. Today, we're going to dig into two really interesting ways to solve a classic problem in mobile networking, something called Snooping TCP and the Wireless Transaction Protocol. We're going to break down what they are, how they tick, and what they can teach us about building for a wireless world.
Okay, so let's get right into it. Here's the core issue. TCP, the protocol that's basically the backbone of the internet, was designed for a world of physical wires. It was just never ever built to handle the chaos and unpredictability of wireless communication. And here's the real kicker. When a packet of data gets lost, TCP automatically thinks, oh, the road must be jammed with traffic, and its only move is to slow everything way, way down. But on your phone, a packet probably got dropped because you had a bad signal for a second, or you were moving between cell towers. The road isn't jammed at all, but TCP doesn't know any better, so it slams on the brakes and your connection just grinds to a halt. So how in the world do you fix a problem like that without having to redesign every single device on the internet? Well, one of the most clever fixes is a little something called Snooping TCP. Now this is where it gets really cool. The idea is to put a smart middleman, called a foreign agent, right at the edge of the wireless network. Think of it like a local manager. It snoops on the data headed for your phone, keeps a copy for a split second, and if it notices an error over that last wireless hop, it just resends the packet itself, right there on the spot. And that's the genius of it. It creates this little buffer zone. It handles all the messy, unreliable wireless stuff locally and super fast. This shields the original server, way back on the wired internet, from ever even knowing there was a problem. So the main server never thinks there's congestion and just keeps sending data at full speed. Which brings us right to a key part of our question today. Can we actually call this approach transparent? Because in networking, that word means something very specific. And the answer is a resounding yes. It is transparent. Why? Because the actual connection between, say, your phone and a web server is still one single unbroken TCP connection. All the clever stuff happens with that agent in the middle. Neither the server nor your phone needs to be changed at all. To them, the fix is completely invisible. But, of course, nothing is ever perfect. Snooping TCP is transparent and pretty easy to roll out, but it has some definite downsides. For one, it doesn't totally separate the wireless link from the wired one. And maybe the biggest issue for today, since it needs to snoop on the data, it has a really hard time if that data is encrypted, which, let's be honest, almost everything is now. So let's switch gears and look at a completely different philosophy. Instead of trying to patch the old system, a bunch of engineers asked, what if we just built something totally new, from the ground up, just for wireless? And the answer to that question was the Wireless Application Protocol, or WAP. Now, WAP wasn't just a tiny fix. It was basically a whole parallel universe to the internet we knew. You can see here it's a full stack of its own rules and layers, sitting right next to this standard internet stack. It was an entire toolkit designed to be super efficient for those early mobile phones that had slow connections and not a lot of power. And this brings us to the other major part of our question. Buried deep inside this WAP architecture is a really critical piece that was meant to do TCP's job, but better for mobile. It's called the Wireless Transaction Protocol, or WTP. You can see it highlighted right here in the diagram. WTP lives in what's called the transaction layer, smack in the middle of the WAP stack. Its whole purpose in life is to manage the request and response chatter in a way that just makes sense for a mobile device. And the entire design philosophy is right there in how the source material describes it. The whole goal of WTP is to offer a lightweight transaction service. Lightweight, that's the key word. Everything about it is built for speed and efficiency. So what does that really mean in practice? Well, it means WTP throws out all the heavy baggage that comes with TCP. It doesn't need all that formal setup just to send a tiny piece of data. It's built for quick, simple transactions, grabbing a stock quote or the weather forecast. It makes those little exchanges reliable without all the overhead, which is absolutely perfect for a slow, laggy network. So what's the big takeaway here? We've just seen two totally different philosophies at war. On one side, you have Snooping TCP. It's a clever patch, right? An enhancement designed to fix a problem while leaving the main system untouched. And on the other side, you have WTP. It's a total rethink, throwing out the old rules to engineer a brand new solution for a brand new problem. And that leaves us with a final thought. This fundamental tension between patching an old system to keep things compatible versus building a new one from scratch to make it perfect.
This is a battle that plays out over and over and over again in technology. How do you think that push and pull has shaped the mobile internet that you use on your phone every single day?